Hi, my name is Star Schroeder. I am from PoSSUM 1802 class. I have had the pleasure of mentoring Team Eurus. They are one of our 2020 Microgravity Challenge finalists. They are comprised of three young ladies, Catherine Merritt, Elizabeth Krapps, and Katarina Krisner, along with their advisor, William Perry. They are all from Maclay School in Tallahassee, Florida. Their microgravity experiment studies the effects of different altered gravity states, microgravity and hypergravity, on lung capacity in asthmatics versus non-asthmatics. They have put a lot of hard work into it, and their hope is that this will better inform the risks and benefits for future space travelers who may not have been trained as well as astronauts that we know today. So without further delay, I will turn it over to them. Thanks.
Hello, we're Team Eurus, and our testing lung capacity in hypergravity and microgravity using peak respiratory flow.
So today we are going to do a meet the team, our experimental background, the phases and procedure documentation, in-flight crew rules, an equipment description, and a special thank you to our mentors. So in the photo you can see team leader Catherine Merritt and Katarina Krisner and Mercy Krapps. And our inspiration we are members of our astronaut challenge team at our school, and we decided to enter into the PoSSUM13 competition because we loved how it was centered around getting females in space. Our idea is to compare lung capacity of an asthmatic when in hypergravity and microgravity to see if there is a decrease.
So the goal of our experiment is to look at if hypergravity and microgravity affect the lung capacity of non-asthmatics as well as asthmatics. We believe that a change in gravity will lead to a change in peak respiratory flow, which will be representative of a change in lung capacity. Our experiment is relevant because of the impending relevance of civilian space travel. There's a different physique between trained astronauts and civilians, and there's a focus on lungs because other experiments testing lung capacity have been done in microgravity and hypergravity, but none of these experiments have specifically been testing peak expiratory flow. Our experiment is cost-effective, can easily provide more data points than previous experiments, and it would be a better representation of the general population. So here's the picture of our peak flow meter. There are 8 phases total for our experiment. Phase 1 is the experiment being performed on the ground to establish data to compare to the results of the experiment that will be obtained in hypergravity and microgravity. Phase 2, the 2 test subjects will go on the flight campaign with peak flow meters. Once the plane starts on the upward part of the parabola and the subjects are experiencing hypergravity, both test subjects will get 2 peak flow readings. These readings will be recorded using the GoPro Hero 5 as well as written down on an e-board. For phase 3, this is the free fall period of the parabola, and both subjects will again record data for 2 trials, and the readings will again be recorded using the GoPro Hero 5 and written down on an e-board. The test subjects will repeat phases 2 and 3 for the remaining 5 parabolas of the first half of the flight campaign. During the level portion of the flight campaign, the test subjects will take 2 more readings in order to compare their 1G results on the flight to their 1G results recorded on Earth, just to see if a change in their numbers might be representative of them being excited rather than actually a result of being in hyper or microgravity. For the remaining 6 parabolas, the test subjects will repeat phases 2 and 3. And then after the flight campaign, the video from the GoPro Hero 5 will be looked at and the data recorded. The data written on the kneeboard will be compared to the data retrieved from the GoPro Hero 5 to make sure both match. We will compare the readings obtained from the test subjects before the flight to the data points retrieved during the flight campaign to determine whether or not hypergravity or microgravity has an effect on a person's lung capacity. We've decided that a change of 10% or more between the average reading of the test subject on Earth and the average readings in microgravity and hypergravity will be indicative of that hypergravity or microgravity has an effect on lung capacity.
So here are the materials that we're going to be primarily using in our experiment. On the left, you have your Philips Respironics peak flow meter, and on the right, you have the Hero 5 GoPro and the head strap that will attach to the subject. So in terms of ground operations, we're going to make sure that the peak flow meter and the GoPro are working beforehand. And so especially we're going to make sure that the GoPro is fully charged and the peak flow meters are sanitized since we are in COVID-19. And we're going to use alcohol swabs to do that. And so we're also going to be sure we have baseline readings for each of the subjects. And so we're going to be using the same model of peak flow meter that we're using in the experiment. And we're going to use these readings as a control to compare against the data that we get from the hyper and microgravity readings. So in terms of loading, it's very simple. We're just going to put the peak flow meter, the GoPro, and the head strap delicately into a storage bin that we will then carry on board the flight. And then for pre-flight, we're going to be sure, like I said, everything is working and tested and sanitized. And then we're going to have test subject A hit go on the GoPro and record. And both subjects will then put on their peak flow meters using wrist straps. And subject B will secure their knee board and marker. So during takeoff and landing, we want to be sure that everyone is safe and try to avoid any emergency situations. So we're going to be sure everything is secure and strapped on. The peak flow meters will have that wrist strap, and the GoPro will have a head strap for subject A. So in terms of flight crew roles, we have test subject A, as I mentioned, and their job will be hit go on their GoPro and take 4 total readings of the peak flow meter for each parabola, 2 during 2G and 2 during 0G. And they will be holding their peak flow meter up to their GoPro to record the data, and they will verbally announce their readings to test subject B, and test subject B will write those down on their knee board. Test subject B will also be taking 4 total readings for each parabola, and they're going to be communicating their readings to test subject A by holding up their peak flow meter to the GoPro, and they're also going to be writing down both their readings and test subject A's readings. So just to go over a few possible emergency and failure mode scenarios, if a subject who has asthma has an attack, there will be medical experts on board, and hopefully the subject will have provided their rescue inhaler, and so that will be given to them. And then if the GoPro fails, as I mentioned, the systems are redundant in terms of our data recording, and so we do have that knee board that test subject B is recording on, so we can just use that data instead. So during post-flight, we're going to carry everything off in that storage bin as before, and we're going to take the video from the GoPro, upload it to the computer, and analyze it for our measurements. And then we're going to compare those measurements to the baseline studies that I mentioned earlier.
So here are 2 videos about equipment description. One is about how to attach a GoPro to the head strap, and one that we will watch today is how to use a peak flow meter. You're going to remove the top, form the handle, and the red marker at 0, and you'll put your lips around it and blow into it. And then that will be the reading. So our first equipment description is about our peak flow meter. It's a Philips Respironics model REF HS755. Its weight is 72 grams, and as you can tell by its length and width, it is like a hand-holdable object, and it's very light. So, then for the GoPro Hero 5, its weight's 118 grams. Its length's 3 inches with the protective case and on stand, and it's 1.75 inches, and it's depicted on the right, so it's pretty small. And finally, here's a thank you to our sponsors. We are so thankful to our many mentors for the help they have continually provided for us. They have met with us every other week to aid us in experiment design and the next steps in legitimizing our experiment, like Dr. Shauna, who has guided us through attaining an IRB, and Dr. Perry, who helped us with our initial research. We have learned so many teamwork skills and so many traits that we will carry with us. Thank you.
Team Eurus, do you have any comments you want to make about your video or answer any questions?
We're happy to answer any questions anyone has. We mostly discussed what we wanted to say in the video. We just want to say thank you again so much for this opportunity. We've learned so much from all of you, and definitely been a very, very fun experience. We've never done anything like this before, so thank you.
Your pleasure. All right. Shauna Pandya raised her hand.
Team Eurus, you've done amazingly, and I've been really Honored to mentor you during this year's competition. If you haven't touched on it already, what are your hopes with the results of your payload once it flies?
That partially depends on what the results are, but I think we're hoping to be able to, I know the possibility of writing a paper has been discussed, which would be very interested in, and as well as, I suppose, looking for opportunities to look into it more in the future, if that makes sense, since this is done on a small scale at the moment with only 2 test subjects.